Assalamu alaikum. Let's start with term 3 focused questions for the end of year exam. First question, with the bright bands are formed due to constructive interference, and the dark bands formed due to destructive interference. So the answer is A. As you know, constructive will give us bright band, let's say, and the destructive interference give us the dark one. Okay. Destructive interference happens when a of wave meets a. Okay. To have destructive should be crest and trough. So, or trough and crest, of course. So, B. The answer is B. The distance between the slits in double slits setup compared to the distance to the screen from the slit is very small, actually. Be careful here. There is mistake in the let's say official answer key. It was mentioned there very large, which is not right. The right answer is very small. Okay. Now, next, what happens if the split separation is increased? Sorry. We know that Y equal Y bright equal lambda times L over D times M. Now, if D increased, lambda Y will decrease. So we can write now our own words here to express this. I will keep the answer key answer. Okay. If the slit separation D, if D increase, increases, okay, the fringe spacing will decrease. Okay, so we'll have narrower fringes. Okay, the color is switched from red to blue. So let's look at the same formula. Y bright equal lambda L over D times M. The blue light has lower wavelength, so we will have lower fringe spacing. So okay, switching. Okay, switching from red to blue means of course decreasing lambda over the wavelength. Okay, and that will decrease the spacing or the fringe spacing, or the spacing between the fringes. Okay, that's it. You can use your own words. Okay, the meaning is the most important part here. Question number 28. Please read it. So the answer here will be use blue light instead of green light. Why? To have closer fringes. Why? Because blue light will have less wavelength than green light. Okay? So lambda blue less than lambda green. That is the main reason. Let's go to the next question. Okay. We need to determine how far apart the slits are. We know that Y equal lambda L over D. For the first one, for the first fringe, this is the formula. So now D equal lambda L over Y. That means 5 for 2 times 10 power negative 9. Of course, we need to be careful that nanometer means times 10 power negative 9. Okay? So, again, let's complete now. L, what is L? L is 1.2. The distance between the slits and the screen. It's 1.2. Over Y. Y is 4 centimeters. Of course, again, we need to be careful that we need to use all lengths in meter. Okay? So D, the distance between the slits, equal to 16 times 10 power negative 6 meter, which is equal to 16 micrometer. Of course, you can leave it like this. You can write it like this. It's up to you. And it's not a big deal. Okay. Next question. Read the question, please. Now, lambda will equal to Y bright times D over L. How did we find this? Let's write the formula as it is in the formula sheet. Y bright equal to lambda L over D. So now take D to the other side, it will be multiplication, and L to the other side will be division. So lambda equal D times Y bright over L. Lambda equal, now let's substitute. D is 1.9 times 10 power negative 5 given here. Y is 13.2 millimeter. Milli means times 10 power negative 3. So 13.2 times 10 power negative 3 over L. L is 0.6 meter. Also, it's given here. Now lambda, after calculations, equal to 418 times 10 power negative 9 meter, and that's equal to 418 times nanometer. Okay? This is 8.1. Let's go to 8.2. Okay, light at, okay, please read the question. We need to find the width of the central maximum fringe. W, the width, equal to 2y1, يعني twice y1, which is equal 2 times lambda L over A. Lambda is wavelength, L is the distance between the slit and the screen. طبعا here we are talking about a single slit problem, not double slit like previous one. So A is the width of the slit itself. So now W equal to 2 multiplied by the wavelength is 410 nanometer, means 410 times 10 power negative 9, multiplied by L, which is 0.29. This is L over A, the slit width. The slit width also is given 3.8 times 10 power negative 6. So the width of the central fringe or central maximum is 0.063 meter. Using the calculator, of course. Now, next question. Also, we need to find lambda here. They give us the width of the central maximum. So, W equal to Y1, same thing like the previous problem, which is equal to lambda L over A. طيب, lambda equal A times 2y1 over K over 2 L1 or 2L. Now substitute lambda equal A is 0.6 times 10 power negative 3 times 2 times y1. Y1 is 10. Let's say 2y1 equal to, 2y1 together is 2 times 10 power negative 3 meter over 2 times L. L is 1.2 meter also. Lambda, using the calculator, lambda equal to 5 times 10 power negative 7 meter. That's it. Next question. Please read the question. We need to find theta, the angle. Okay, D sine theta equal M times lambda. That is the formula we have. So now sine theta equal M lambda over D. Sine theta equal 2 times 500 nanometer, which is mean 500 times 10 power negative 9 over d, which is 2 times 10 power negative 6 meter. Using the calculator, shift solve theta equal to 30 degrees. Of course, we need to use, if you don't want to use shift solve, so you say theta equal sine inverse, and you put the result of this fraction. Okay. Now, next question. Okay. Compare between the spacing between the bright bands among those three beams. Okay. طبعا we know that d sine theta equal to m lambda. If lambda increase, d sine theta will increase. That means the highest wavelength have the highest d sine theta, and the lowest wavelength will give us the lowest d sine theta. So violet will be the lowest, of course, because it has the highest frequency. That means the lowest the lowest wavelength. So this is the answer. If we want to write y for the same diffraction, grating, and same order, of course, and same M order. Okay, the relation between the bright bands is directly proportional to lambda, the wavelength. So larger wavelength means larger angle. Okay. يعني wavelength directly proportional with theta, which is give us the answer C. Okay. Let's now go to 8.3. As we know, for the polarization, the filter, if we polarize the unpolarized light, for the first polarization, filter will give us 50% of the intensity of the light. Okay, next. Here at the beginning we had, please stop the video and read the question, okay? The first filter, we are decreasing the intensity by 50%. So I1 equal I0 over 2. Now, for the second one, we will look at the angle. So I2 equal I1 times cosine squared theta 2. Be careful, the squared in the cosine, not on theta, please. So when you write it in the calculator, write it like this. I2 equal I1, which is I0 over 2. طبعا this one based on the formula we had here, or based on the result. Now cosine 45. That's how we should write it in the calculator. Put the cosine and the angle between two brackets and write squared. That means I0 over 2 multiplied by 1 over radical 2 squared. So the answer is I2 equal I0 over 4. So we just used the formulas we have and found the answer. Thank you for watching. Inshallah, for topic 9, I will do another video.